Lesson 10.3 is all about arcs of a circle. We're going to start with a handful of definitions that have to do with parts of the circle and the measurements and basically just the arcs. The definition of arc is it consists of 2 points on a circle and all the points of the circle needed to connect the points by a single path. So to connect A to B, there are actually 2 different arcs. There is AB going this way, but then you could also go clockwise to connect them. Now, these would be 2 different types of arc. The smaller arc, going counterclockwise, is considered the minor arc, while the arc going clockwise is considered the major arc. The center of the arc is just basically what the center of the circle is. It connects the 2 points of the arc to the center. The central angle is an angle whose vertex is at the center of the circle. So this would be central angle AXB. As you probably already know, a semicircle is half of the circle, and it's formed by making a diameter. So BC would be considered a semicircle. It's 180 degrees, and again, half of the circle. To calculate the measure of the minor arc, you would just simply take the central angle. So if this was 60 degrees, the measure of arc AXB would be 60 degrees. To take the measure of the major arc, you would take that central angle and we would subtract it from 360. So the measure of the major arc would be 300 degrees. Two circles can have congruent arcs, especially if they're a circle within a circle sharing the same center, or inscribed circles. What that means is that the measurement of this arc and that arc are congruent, the measurement angle of that arc. Now, the length of those arcs would not be congruent, and you can see by obvious reasons just because the circles are different sizes. But again, the measurement angle would both be the same. Now we have a handful of theorems having to do with arcs and the congruencies. Pause the video and copy down the theorems and we'll talk about them. They really are just playing off of each other, so once you know one or a couple, the rest should kind of fall into place. Here's what all these theorems are basically saying is, if you look at the first circle down here, if we have congruent chords, it can imply that we have congruent arc lengths, or congruent measurement of the arcs, or we can have congruent measure of the central angle, or vice versa. If we know that the central angles are congruent, we can say that the arcs of the circle are congruent, or that the chords are congruent. First example, let's say we're given the following diagram, and we know that the 2 chords are congruent. Based on the theorem above, since the chords are congruent, that tells us that the central angles must be congruent. Therefore, if this angle is 70, x has to be 70 degrees. And here's our second example. Given the following diagram, we want to find the arc K. So we know that this arc right here is 70 degrees, And then we know that these are all congruent, which then tells us that these three arcs have to be congruent. So what we do is we take 360, because we know that is what a circle is, subtract 70 from it, we get 290. And since we know those are all congruent, we'll divide that by 3. And that gives us 96 2/3 degrees, which would be K. The last thing we'll look at is a proof. Given the following information, circle E, and that EF is perpendicular to DC, EG is perpendicular to AB, and EF is congruent to EG, prove arc AC is congruent to arc DB. So as always, we're going to start with our given. And since we know that EF is congruent to EG, that tells us the two chords, DC, is congruent to AB. And that's based on the theorem from the previous section. If two chords are equidistant from the center of a circle, then they are congruent. And if we know that the chords are congruent, what that's going to tell us is that DC and arc AB will be congruent. If two chords of a circle are congruent, then the corresponding arcs are congruent. Now, if we look at what we're trying to prove that AC is congruent to DB, and you'll notice that they have an overlapping arc right here of AD. So we can use the reflexive property, AD congruent to AD, and then that will bring us to AC is congruent to DB based on the addition property.